Okay. I have one more question like this. Okay, look at this question. Here, an oxide of an iron dissolved in an inert solvent and is electrolyzed for 2 hours using a current of 0.8 ampere. So here I have got a time. Okay, and here I have got a current. The electrolysis products are iron and oxygen. The mass of iron produces 1.11 gram. So they have provided you the mass. They have provided you the time for which the electrolysis is being performed. And the current. Now, see the question. Calculate the oxidation number of iron in the oxide of iron. Show all your working. Yes. Yes. You have to find the oxidation number over here. How could you do this? Yes. Okay, then have a look over here. We don't know the oxidation number, right? So, but they have given me the mass of iron produced. So if I try to make the equation, iron is basically for in the form of a cation in its aqueous solution. So it means that this reaction is actually took place at cathode. Okay, so I can write this in this way. I don't know the charge. What is the oxidation number of iron? So I can put a n plus, which can be 1 plus 2 plus 3 plus 4 plus. So if it is getting reduced at cathode, how many electrons it will gain? N number of electrons. And as a result, 1 mole of iron is deposited. Is this understandable? Yes, this equation is understandable to everyone? Yes, if anybody have any doubt, Alishka, Mahi, Mubashir, Musa, Saliha, Usman, Talha, Zaid. Okay. Yes, is this clear to everyone? Okay. So if you look in the data booklet, in the periodic table, what you will find that what is the mass of 1 mole of iron? Can anybody check and tell me? What I recall, it is 55.8. Yes, can anybody confirm it?
Yes, 55.8.
It's 55.8. Okay. So for this is the mass of 1 mole of iron. Okay. And for this 55.8, we need what is the charge of 1 mole of electron? 96500. So I can say that it can be 96500 times n, and the n actually, if I am able to find the value of this n will tell me the charge, and it would be actually the oxidation number of the iron metal. Okay, so during the experiment, 1.1 gram, 1.11 gram of iron is produced. Right? And this iron is produced from 2 hours time and 0.8 ampere. So I can make the charge over here 2 hours into 60 into 60 to convert it into a current seconds and times 0.8. So this is the Coulomb charge that is provided during the experiment that is performed, and for that charge I am getting 1.11 gram of mass. So if I'll make n subject, it would be 0.8 times 2.0 times 60 times 60 times 55.8 divided by 96500 into 1.11. No. But why 0.03? It must be 3. So 0.03 क्यों बोल
3 है
3 आएगा 0 नहीं आएगा. Yes, it's positive 3. So it's 3. So it means the oxidation number of iron is positive 3 over here. So in that way you have to attempt, you are going to attempt these questions if they ask you for the oxidation number. जी हाँ, आप गलत कर रहे हैं, दोबारा कर. ये सलीसा 3 आ रहा है, बेटा दोबारा वैल्यू पुट कर. जी, yes, is this clear to everyone? Okay. Is this clear to everyone? No? Okay, I'm going to give you another question like this for the oxidation. Okay, it is for mass, and we did it in the last class, right? So see, calculate the mass. If you see the question, calculate the mass of lead that is converted to PbSO4 when current of 0.4 ampere is delivered by the cell for 80 minutes. So this is the mass of the lead, and here I got the electrons. So I can just take the ratio between these two. Can anybody tell me the AR of the lead quickly? Is it 204 or 127? 106.4. 106. No. Lead is in group 4. So the charge is 2 times 96500 coulomb. Sorry? 207.2. So that ratio I got it, that twice of 96500 coulomb charge is actually consumed or is actually used up to form 207.2 grams of lead into lead sulfate. Now in the experiment, there is a 0.40 ampere current into 80 minutes, and I must convert these 80 minutes into 60, and I make it this x. So x would be the mass. So x is equals to 207.2 into 0.40 into 80 into 60 divided by 2 times 96500.
2.1.
2.1.
Sir, 2.06,
Okay.
sir.
2.06. Okay, if there are three significant figures, so you may write 2.06, not 2.01.
सर लेकिन हर चीज तो 2 सिग्निफिकेंट में दी हुई है ना, तो हम 2 सिग्निफिकेंट में नहीं।
If that is the examiner mentioned that you need to write the answer in two significant figures.
लेकिन लिख तो सकते हैं ना?
नहीं, you always write the answer in the three significant figures until examiner says you to write in two or any other. Okay.
ठीक है।
Okay. Now it's for you guys. Do it and WhatsApp me quickly. And how you would make the equation? There is a help over here. If you see, if you read this statement, the student used the acidified solution of dichromate to electroplate a steel box with chromium metal. So it means that during the electrolysis, that this is gaining some number of electrons and forming chromium metal. And here 2 moles of chromium metal are being formed because there are 2 chromium. So first you have to figure out this number of electrons over here and then do this part. Okay, do it quickly. This is from the yeah. Yes, Abdurrahman, can you tell me the number of electrons? Yes, Abdurrahman. Mariam Khan, can you tell me the number of electrons? Alishba.
Sir, I
So
don't
it will
know.
be 6 electrons.
Yes, yes, Sanjay, can you repeat?
No, sir, I don't do.
Yes, Mariam, you were also telling me
Sir, 12.
12.
Sir,
Okay,
6 electron.
Mariam suggested 12. What else? 6 electrons. What are 6 electrons being used over here or 12? Are you sure?
The -2 positive 14 positive 12 divided by 6.
So 6 is the oxidation number of one chromium atom. Here you are forming 2 chromium atoms. See. If you have found +6, that is the oxidation state of one chromium. Okay. Okay. But if you see here, there are 2 chromiums, and both the chromium have a +6 oxidation number, and both the chromium are converting into chromium metal. So if I am using Cr2O72 negative, so I must need 12 electrons, 6 electrons for each chromium atom. Yes, is this clear to everyone? Yes, Mariam, very good. So if you figure that the +6 is the oxidation number of one chromium, but here as we are 2 chromium atoms are being formed, so there must be 12 electrons over here. Is this understandable? So now you got the ratio. Now you do the further calculation. Just show me your work. And everybody else will, as you complete it, WhatsApp me. Yeah. Because you are from. Yeah.
तो मैं पहले ये अगर 60 कर दे तो आंसर आ जाएगा।
हाँ, 6 और 52
हाँ तो आंसर फिर ये बन 2779
सर 2779 आ रहा है।
Okay. Send me your working, sir. Everyone else, as you completed, send me your working quickly.
सर व्हाट्सएप करो।
Yes. So we can attempt this question by two ways, either relating 6 electrons with one chromium or 12 electrons with 2 chromium. So 6 times 9, 6,500 is 252, and here 12 times 9, 6,500, twice of 52. The mass that is obtained is 0.0312 gram, 0.0312 gram, and here what I need? Charge. So charge is equal to 0.125, that is a current, times T. So 0.125 times T. You calculate the T, you get the answer. So T is equals to 6 times 9, 6,500 into 0.0312 divided by 0.125. Okay, I told you we got that. For 12 electron, there are 2 chromium. So either I can do this or I can do this. Because if I simplified it for a 1 chromium, there must be 2 instead of 12. There must be 6 electrons over here. Okay, you send the answer. Okay, Rita. That's fine. So here T is equals to 0.12 into 96500 into 0.0312 divided by 0.125 into 2 into 52. Both gives you the same answer. This what answer we are getting over here. Yes. 2779.2. Okay. So 2779 seconds because these are seconds. Yes, is this clear to everyone? So 779 to the 3 significant figures. If you convert it, how many difference you will be getting? It's a seconds. Okay, now do this one. Do it quickly and I want the answer from every one of you on WhatsApp. Okay? Now here again you have to find the value of n. That is the oxidation number of chromium.
n is equals to 3 है.
Sorry?
3.
Sorry. आप मुझे वर्किंग भेजिए. Send me your working.
चार्ज हुआ है लैपटॉप पे कर रहा हूँ.
So send the screenshot or the picture from the laptop.
सर आपको मैं बता ना दूं.
Don't tell answers, send your working. Just kindly WhatsApp me quickly. Yes, 3. That's good. Okay, sir. Good. Okay, Mariam. Good. Salha, very good. Okay, who sent me no question? Good. So the chart would be 3 positive. Okay, the oxidation number would be 3 positive over here. Okay, Simon, I received yours as well. So have a quick look. See, as the equation is given and we don't know the number of electrons over here. So we assume that the charge is 96500 coulomb times N, producing 1 mole of chromium, which AR is 52. And during the experiment, the charge and 0.776 gram of chromium is formed. So I have to find the value of X, which is actually the oxidation number of chromium. So here the value of N would be equal to 1.8 into 40 into 60 into 52 over 96500 times 1.8 times 40 times 60, and here you are getting around 2.99, which would be round off to 3.0. So the oxidation number of iron over here is positive 3.0. Oh, sorry, positive 3. Is this clear? Mr. Law. Okay, now the next thing that is related to this electrolysis, that is the last thing, and that is the justification or the verification of our Avogadro's constant. And we all know that Avogadro's constant is equal to, yes, Avogadro's
6.02 exponent 23.
Avogadro's constant. Okay, here we represent Avogadro's constant by L, capital L, and it is equals to 6.02 exponent 23. Okay, we can justify this figure. What this figure represents basically? Number of particles in 1 mole. This figure represents number of particles in 1 mole, right? Particles in 1 mole. So through electrolysis, we can justify or we can prove this constant. And for that, we use this relation that Avogadro's constant is equals to F over E. Where what is F? F represents the 1 mole of, sorry, F represent charge of 1 mole of electron, and E is the charge of 1 electron. Okay. So we are going to use this expression. Now, the important thing over here is that you have to keep in mind whenever we talk about the charge of 1 electron, it is always 1.6 exponent minus 19 coulomb, and that is provided to you as well in the data booklet or in the end of the paper. Okay, and you all also aware of the charge of 1 mole of electron, which is 965 double zero coulombs. So yeah, but the thing over here, when we are using this expression, remember, whenever you are using this expression, we do not use 96500 coulomb. Okay, because that is the constant, that is the theoretical value. Instead, we calculate this from data that is provided over there. So while attempting the question where you have to justify or prove or find the Avogadro's constant, you don't use, remember, you don't ever use that the 1 mole of electron is 96500 coulomb. You calculate the charge of 1 mole of electron from the data provided. Is this understandable to everyone? Yes.
Yes.
Okay. So in previously all of the cases we use this constant 96500, but here whenever we are doing the question in which we have to use this is equals to LE. In either case, we don't use. Okay. Okay. So see in this part, first they have asked you the relation, state the relationship between the Faraday's constant and the Avogadro's constant. So Faraday's constant is equals to Avogadro's constant times, no, yes, F over E tha na. So that is the your relation, or you can write in this way that L is equals to F over E. No, you have to write the expression. Okay. You don't write directly proportional, you have to write the whole expression over here. Okay. Now, see, when a current of 1.2 ampere was passed through dilute sulfuric acid for 30 minutes, I have a current, I have a time. It was found 130 centimeter cube of oxygen. The volume produced at 25 degrees Celsius and 1 atm pressure was collected at anode. The following reaction takes place. They have given you the equation as well. Use the data and data from the data booklet to calculate the value of Avogadro's constant L by calculating. So just give me a minute, please. Okay. So in this part, if you see, they have told you what you need to do. So first, what you need to do? Number of moles of oxygen. So how can I do it? Okay. Let's make these points 1, 2, 3, 4, 5. So point 1, I have to find the moles of oxygen and I have given with volume of oxygen. So how I can find the moles of oxygen?
सर 130 को डिवाइड बाय 1000 करके डिवाइड बाय 24 डेसीमीटर क्यूब कर दें.
Okay, we got the volume 130 centimeter cube. So we just divide it by 24,000 centimeter cube because it's the volume of the 1 mole. So we got the number of moles of oxygen. Yes, so this part is clear. Yes, can anybody tell me the answer, please? 5.41 into 10 raised to the power minus 3 moles. 5.41. Yeah, so it's 5.42. So that is that they have told me to do. Then in the second part, the number of moles of electron needed for this.
सर 96,500 ऐड नहीं करनी.
No. Yes. Number of electrons needed for this. So what I'm observing that for 1 mole of oxygen, how much electrons are needed? Yes. For 1 mole of oxygen, how many moles of oxygen electrons are needed? From the equation only. Moles and electrons. How many moles of oxygen are over here? 1. And how many electrons are needed? Are there? 4. So 1:4. And here I have 5.42 exponent minus 3 moles. So x moles of electron. Yes, so x would be 5.42 exponent minus 3 times 4, right? Yes, what is the answer over here?
Sir, I'm getting 10.7.
See, look at the equation Z. From the equation, what I concluded that 1 mole of electron, sorry, 1 mole of oxygen needs 4 electrons, right? So that ratio I have took over here. For 1 mole of electron, for 1 mole of oxygen, I need 4 electrons. So if I found the moles of oxygen over here, right? So these moles needs x moles of electrons. So to find the x, I have to multiply it with 4. So what is the answer over here? 0. रुक जाएं 217 भी कर सकते हैं 0.02 आगे फिगर बताएं मुझे पहले जस्ट टेल मी द होल फिगर 0.02168 see this is the answer if you got so normally we do write these kind of answer in scientific notation if we have a more than one more than one number over here so if I turn it into scientific notation, it would be 2.1. And if I now use 3 significant figures, so it would be 2.17 exponent minus 2. So these are the moles of electrons. Here they are the moles of oxygen. Now in the third part, the number of coulombs passed. Yes. Yeah. During this experiment, I have uses this amount of current, 1.2 ampere, for 30 minutes. So how much coulomb is passed? That is calculated by the current and the time that is used in the experiment. So for third, Q is equals to I into T, where I is 1.2 amperes and T is 30 minutes, which I have to convert into seconds. So 30 into 60. So 120 into 1.2. Yes, can anybody tell me the answer? Yes? 2160 coulombs. So I'm done with the first part, second part, third part. Number 4, the number of electrons passed. Yes. How could you do the fourth part? आप जाएं? In the fourth part, you have to find the number of electrons passed.
सर डिवाइड बाय 1.6 एक्सपोनेंट -19 करेंगे
क्यों करेंगे?
सर उससे आपको टोटल इलेक्ट्रॉन्स पता चल जाएंगे ना इसमें.
Okay. So what we know, we got the charge, right? We know that if there is a one electron, for that one electron, the charge is 1.6 exponent -19 coulomb, right? So if this is the charge, then there must be x number of electrons. So we got the number of electrons by this ratio.
1.35 exponent 22.
I have told you, whenever we are doing this and we have to find the L, the Avogadro's constant, we do not use that constant 96500. Okay, that's what I have told you earlier over here. We do not use this value whenever we are observing this relation. Whenever we are doing any calculation regarding this relation where we have to find the Avogadro's constant, we do not use this value. Okay, so yes, what is the answer over here? So x is equals to 2160 over 1.6 exponent -19. 1.35, there is no other figure after 35. And exponent 24. 22. So these are the electrons. That is the fourth part. Now the number of electrons in 1 mole of electrons. You have to do the fifth part. But think, here they have asked you to do in this way, and in this way we are done with all these, right? And I have to now find the mole L. And what is L? The number of electrons in 1 mole, right? So can I relate these two? What are these two? These are the moles of electron, and these moles of electron have actually this much electron. That is the mole, see? And these are the number of electrons. So in the second part, I calculated the number moles of electron. And in the fourth part, I have calculated the total electrons that are present in that number of moles. So I got this relation, right? So in the fifth part, I'll apply this relation that 2.17 exponent -2 are the moles, and these moles have 1.35 exponent 22 electrons, right? So if I have a 1 mole, then there must be x number of electrons. So remember, we don't ever use that relation that 1 mole electron have 96500 coulomb charge whenever we are finding the Avogadro's constant. So find the value of x. So x would be 1.35 exponent 22 divided by 2.17 exponent -2 6.22 into 10 raised to the power 23. So see, in this way you didn't always get the exact 6.02 exponent 23. You will either be getting 6.1 exponent 23 or like this 6.2 exponent T3 or 5.99 exponent 23 sometimes as well. Yes, is this understandable to everyone? Yes, Alishba, Abdurrahman, Ahmed, Mahin, Mariam, Muiz, Mubashir, Sanwin, Saleha, Musa, Talha, Zaid. If anybody have any doubt, kindly ask. Is this clear? Okay,
Yes,
now
sir.
I'm going to give you a question like that and you have to do it. Electrochemistry always takes so much time. अब बाहर जाके बात करके आ जाए. Okay, here you have a question. I think it is readable by everyone. Yes, we will do Mubashir that well as well. Okay, first attempt this, then we will proceed further. Okay, I think first part is easiest. That F is equals to L times E, or L is equals to F over E. Draw a diagram of suitable apparatus for carrying out this experiment. Which experiment we are carrying out? Electrolysis, right? So for the electrolysis, we need a one container, a positive terminal, a negative terminal, and the electrodes are dipped in electrolyte. So that is your cathode, and here it is anode. That is aqueous copper sulfate solution, right? Okay, do one more thing. Always put an ammeter, okay, in the circuit, because yes, we need it, because we need to know how much current is passed, because we are going to get the to calculate the charge as well, right? So always put an ammeter. Everybody is done? Okay. Now, I need the working. Do it and then send me on WhatsApp. Okay? I need a working from every one of you. Do it and WhatsApp me. And if you stuck somewhere, do ask. Just give me 2 minutes. I will be back in 2 minutes. Till then, try to attempt. Yes. There is no need of the oxidation state of a sulfur. Because see, there is a change in the mass of copper cathode, right? So we just need the mass of the copper only. Yes. Can anybody able to complete this? Okay. So see over here, if you look at this, the mass of copper cathode is increasing, and if you see over here that they have given you that the mass of copper deposited on the cathode, so it means your equation would be only this, that Cu2 positive gaining 2 electrons and forming copper solid. From here you can start. What would we do next? This is your equation, but let me recall you one thing. As you have to find the L, that is the Avogadro's constant, so I cannot relate with 96500 Coulomb. Right? I have to figure it out. So what I'll do, Okay, do it yourself, then I'll tell you. Try to do it on your own, then we will discuss. What you need two things. When it is provided to you, that is the chart of one that is 146 exponent minus 19. You need the chart of one mole of electron, that is 1 Faraday. Who left the class? So, and as I told you that you have to variables. You have to calculate that charge. So, yeah, F and F is the chart of one mole of electron. So, for two, if there are two moles of electrons, so I make it 2x. Is 2. Mass of copper, how much? Mass of copper 1 mole have. It is the mass. No, that is the mass of 1 mole of copper. For 2x, 1 mole of a copper, mass of copper is deposited. What is the mass of 1 mole of copper? It's yeah. Why don't you know? 652. Point. No, it's not copper. Copper doesn't check. It's 55.6. It's 63.45. G. 63.5. No, not 52. Okay, who can attend every person this and send it to me? Nobody. Okay. Have a look over here on your screen. From the equation, what I am concluded that there are 2 moles of electron, and as I have told you, to find the charge of 1 mole of electron, that is 96500 coulomb, I cannot take that charge. Instead, I calculate it whenever I have to find the Avogadro's constant. So I make it, let's suppose 2x is to copper. So why I'm going to use the mass of the copper, because I know the mass of the copper that is getting changed. So for this much charge, the mass of copper deposited would be, here are the files, and it's A level. So you can take the value from the periodic table. It is 63.5, right? So that is the ratio I have got over there. That the charge of 2 moles of electron, I keep it unknown, I keep it x, and for that I am getting 63.5 grams. Now, during the experiment, what is the change? Yes, can anybody tell me the difference over here? 0.29. Sorry? 0.29. 0.299 grams. So, during the experiment, I am getting 0.299 grams, and by using the charge of 0.5 times 30 times 60. So from here, I can calculate x. So x would be 0.5 into 30 into 60 into 63.5 over 2 times 0.299. So this x could be basically the F, or the charge of 1 mole of electron. Yeah.
कॉपर की ऑक्सीडेशन नंबर आपने कैसे ढूंढी? पॉजिटिव 1 भी हो सकती है, ये चीज नहीं है, और नाम पर भी दिया हुआ है।
1 minute. If the charge on electron, the AR and the valency of copper are known, okay, the value of Avogadro's number can be determined experimentally. This is done by passing a known current for a known time through a copper electrolysis cell and weighing the mass of copper deposited on cathode. Okay, so we assume that if we are performing the electrolysis, whenever we are performing the electrolysis, which electrolyte we usually use? And in copper sulfate, what is the oxidation number of copper? It's +2. Okay. Yes.
How did we come up with this ratio?
Which ratio?
This charge of moles of electrons.
Because here there are 2 electrons. So we keep it 2x because we are not using 96500 over here. That is the theoretical value. But here we don't use the theoretical value. We will calculate the charge of 1 mole of electron from this. And why we choose the ratio against mass? Because here I am provided with the mass in the question. So that's why I am keeping the charge and the mass ratio. Is this understandable to everyone? Yes, if anybody have any doubt, kindly ask and kindly tell me the value of x. Yes, Alisa, you were asking something? Sorry? Okay. Yes, what is the value? Yes, the online students, is it clear to everyone? Samin, Musa, Muiz, Mariam, Mubashir, everyone else? Mahi, Iza? Zabir Rahman is there. Nobody left. Usman left. Okay. 95568.6. 95568.6. So this is the coulomb charge that 1 mole of electron carries that I have found experimentally. Is this part is understandable? Yes. So to find the value of L, we have F over E. We got the F, that is 95568.6 over E, which is the charge of 1 electron, that is 1 exponent minus 19. Yes. 5.97 into 10 raised to the power 23. Confusion, do ask. Yes, is this clear to everyone? Okay. Now after this, we have 2 more concepts or 2 more subtopics. One topic relates to calculating E0 cell values by using this expression, E reduction minus E oxidation. Okay. So whenever examiner asks you to find the E0 of the cell, what we would do? We would do E reduction minus E oxidation. That is the one thing. where in reduction it is always the greater value and the one we choose the to be oxidized having the smaller value. There is another purpose of this expression. So from here I can get the E naught cell. So I myself choose the half equation having the greater E value to be reduced and the half equation having the smaller E value to be oxidized. Is this understandable to everyone? Yes. The second thing that we do from this expression is the feasibility of the reaction. And for that feasibility of the reaction, I would again do E reduction minus E oxidation. But the only difference here, when I'm using the same expression, E reduction minus E oxidation, but now I don't choose E reduction on my own as I have choosing when I have to calculate the E naught cell. Okay, try to understand this difference. When you have to calculate the E naught cell, you will do the thing that E naught reduction minus E naught oxidation for the half equations. But here, you would choose yourself which one is going to be oxidized and which is one is going to be reduced, and which always choose the one which have a greater value to be reduced and one with a smaller value to be oxidized. Is this understandable to everyone? But when it comes to the feasibility of a reaction, in that case, we do the same thing that we do subtract E reduction minus E oxidation. We do the same thing, but here we don't choose on our own. Instead, here, species reduced and oxidized is given by examiner. Okay, here is the species which is getting reduced and which is getting oxidized is always given by the examiner, and you have to subtract it. And on subtraction, doing E reduction minus E oxidation, if you are getting the positive answer, then or otherwise there is a possibility that when you do this same, you will get the negative answer. So if the answer is positive, then the reaction is always feasible, and if the answer is negative, then the reaction is not feasible. But when I am finding the E naught cell, I am always getting positive. I will never going to be get the negative answer because I am choosing the half equations very carefully depending upon the values. But when I have to find the feasibility, I do not choose the equations which is going to be reduced and which is going to be oxidized. That is always provided by the examiner. And on that condition, if I get the positive answer, then the reaction is supposed to be feasible. And if I get the negative answer, then the reaction is not feasible. Is this understandable? Yes.
Opposite.
If the value is negative, then it's a feasible. And if the value is positive, then it's not feasible. Yes. Is this clear to everyone? Okay. There is one other thing that I need to discuss. Okay, first tell me everyone, can you, if you observe a half equation, just 1 minute, Mubashir, you were saying that the reaction will occur condition worse than. If E cell value is higher than 0.3, then that means the reaction will occur in condition worse than standard conditions. No, that's not the case. Then the case would be some other thing that's not. If you will find, you do share it with me. Okay, Mubashir? Okay, I recall this is the case that if okay, the case is like this. If I recall that if you get the answer positive and it is under positive 0.3, under this range, then we can say that this reaction is feasible in standard conditions, but we cannot take the surety of its feasibility under non-standard conditions. That there might be a possibility that when the reaction, when we do perform that reaction under non-standard conditions, it can be feasible or it cannot be feasible. We cannot tell anything. But if the reaction is feasible and in under standard conditions, and its difference is positive point greater than positive 0.3, then I can surely say that under non-standard conditions, the reaction is also feasible. This is the condition, Mubashir. Is this understandable? Okay. So I am repeating again. If we are getting the positive value, then the reaction is feasible. And if we are getting the negative value, then the reaction is not feasible. This is the first thing. Then, if the positive value is lower than 0.3, then we can only say that reaction is feasible in standard conditions only. And we cannot say anything about when the conditions are non-standard. It can be feasible or it cannot be. But if I am getting the positive value and greater than 0.3 in standard conditions, then I can assure that this reaction is also feasible in non-standard conditions as well. Is this point is clear? Yes, everyone, is this point is clear? Okay. Now, another important thing that I have to discuss over here, and that is the, the thing which is in which always students get confused. First, if you have a half equation written, can you figure it out whether the forward reaction is reduction or oxidation? Yes, Alisa. Yes, Muniba. Yes, everyone else. Yes, Sawan, Iza, Maheen, Soleha. Can you, looking at a half equation, can you predict whether the reaction, the forward reaction is exothermic or endothermic? Can you able to do or not? Okay, but for half equation, it is really very easy. How? That in half equation, whenever there is a electrons are on the product side, then it means your forward reaction is reduction. And in half equation, it's a negative charge and it is becoming a neutral by leaving the electron. If the electrons are on the right hand side, then the forward reaction is always oxidation. That is the easiest way. Yes, I'm talking about half equation. And in half equation, you have always the electron. So if you have seen the electron in the equation and that electron is on the left side of the arrow, then it is always reduction. And if the electron is always on the right side of the arrow, then it is oxidation. And we are talking about the forward reaction. And when I consider the backward, it is always the opposite. Okay. So it means here the reduction is occurring and here the oxidation is occurring in the right direction or in the forward direction. But when I consider the backward direction, here it is oxidation and here it is reduction. Is this clear? Yes, Alishba, Iza, Maheen, Mariam, Moiz, Mubashir, Sanwent, Soleha, Talha, Zaid, Musa. Yes, is this clear to everyone? Okay. So whenever you look at data booklet, let me do this again. I have did it earlier as well. Whenever you are choosing the equation from the data booklet, in data booklet, all the half equations are in the form of, reduction. The forward reaction is reduction and the backward reaction is oxidation. Remember, the forward reaction is reduction and the backward reaction is oxidation. Okay, but just in alphabetic order. Okay, let me choose some values from here. So see, all of these equations are in terms of reduction as the forward reaction, because if you see, the electrons are on the left hand side, and all of these equations have a backward reaction oxidation. So remember, these all are oxidizing agents and these all are reducing agents. Okay, it means I am talking about not H positive ions, I am talking about all these species. These all are considered to be oxidizing agents because they are all undergoing reduction, and these, not this, these all are going to be considered as reducing agent because they are undergoing oxidation. Okay, now there are two more things that you need to remember. If the E naught value, that is over here, is greater, so which reaction would prove most likely to be happen, reduction or oxidation? Reduction. Okay, so it means reduction would happen, and if E naught is smaller, then oxidation would happen. Is this point is clear to everyone? Yes, if anybody have any doubt, kindly ask. Yes, is this clear? Okay. Now, I am going to give you two conditions and I am going to ask you, think very carefully and then answer me. If mixing nickel to positive ions and hydroxide ions. Now, would the reaction occur or not? You have all the equations on your screen. Do use these equations only and tell me. Yes. Think and then tell me. Look at the equations, choose the equation, and then tell me if I mix these two aqueous solution, would reaction occur or not? Yes, Mubashir is saying yes. And I need the suggestion from everyone else as well. Do put in your suggestion. Yes, the online students can comment in chat. Okay.
Yes, sir.
Okay. Mohammed Sheikh is also saying yes. Yes, Sanwin. What do you say? Soleha. Just type in chat. Iza, Maheen, Sanwin, Mariam, Mobile should have done it. Talha, Musa. Everyone just put in chat. And what about you guys? Talha is saying yes. Mariam is saying yes. Mubashir is saying yes. Mohammed Sheikh is saying yes. Yes, I need the suggestion from everyone else. Please put in that chat your comment. Yes, Alisa. Yes, Muniba. Yes. Yes. Okay, did I get further? Savant is saying yes. Yes, Iza, Soleha, Maheen. Maheen is saying yes. Okay.
Not feasible.
But unfortunately, the reaction would not occur. Yes, and I'm not expecting from everyone that everyone is going to say yes. And unfortunately, the reaction would not occur. Think again. What we said that the one having a E naught value greater would undergo reduction, and the one with a E naught value smaller would undergo oxidation. So see, here I have a hydroxide ion, right? I hope everybody choose this equation. And here I have a Ni2 positive, right? Yes. So see, if it's on the left hand side, so it have to be reduced, right? And if its value is smaller than this one, so how could this undergo reduction over here? If it have to be reduced, its value must be greater than the one which is going to be oxidized. So that is the key point that you have to understand. And that is the confusion that mostly students get and attempt the question in the wrong way. So you just observe that one have a smaller value and one have a greater value, so the reaction could happen. But no, it could not be happened. It cannot take place because I don't have a nickel. See, if I would have mixed instead of this, my comment is no. But if I mix nickel with HO2 negative, then yes, the reaction could happen because now this is my reactant and it have a greater value and it can undergo reduction with this because it have a smaller value, so it can easily undergo oxidation. नहीं आया, ये बात समझ में नहीं आती. Okay. Okay, first tell me which can undergo oxidation. Yes. Okay, first discuss this, then we will go to the next case. What we have seen that I am mixing the nickel with hydroxide ions, right? and you all say that the reaction would occur. If nickel is reacting, so would nickel 2 positive ion is undergo oxidation or reduction? For this, first decide this. If nickel 2 positive is reacting according to this half equation, then the nickel 2 positive ion would undergo oxidation or reduction. Reduction. Yes, is this agreeable with everyone? Everybody understand this, that if this nickel 2 positive reacts, it will undergo reduction. And if you see its value, it's minus negative 0.25. So now come to this one. If according to this half equation, if this would react, this would oxidize or will undergo oxidation or reduction? This would undergo oxidation or reduction. Why? Electron oxide का है ना, तो forward reaction beta reduction है ना, that forward reaction is reduction. But I have this as a reactant, so obviously it would go backward. So if it would go backward, then it would go oxidation and it would go reduction. Is this clear? Yes, first tell me, is this point is clear to everybody or not? Yes, Iza, Mahi, Mariam, Mubashir, Sanwan, Talha. So we have decided the one which undergo reduction have a greater E naught value, and the one which would go oxidation have a smaller E naught value. Now, if you compare the values, you would find where we are choosing that the reaction would go reduction have a smaller E naught value than the one which would have oxidation. So it means the reaction would not take place. Yes, then it would happen. Or the other way, for example, if I have this reactant and this reactant, then the reaction would take place. Because if the nickel element would have my reactant, then it always undergo the backward reaction, which means it would undergo oxidation. And this would undergo the forward reaction, which means it would go reduction. And if you see now, this one have a greater value and this one have a smaller value. Yes, is this understandable to everyone? If anybody have any doubt, kindly ask. Yes, is this clear? So you have to take this concept, you have to decide that, and if you have understood this thing, then there is no difficulty you can face in electrochemistry. You have to always keep this concept in your mind. That is the key concept, that which would go under oxidation, which would go reduction. Okay. So now let's try to apply this thing. Okay, let's start from the end. Okay, just wait. I'm just ending the class over here only because we have to start the paper 5 session in next 20 minutes. So see you guys at that session, and from here onward we will continue in the next class from this thing. Okay, and afterwards we will do the next equation as well, and then you have to do a lot of practice past papers. Okay, so at 5:15 we will be continuing paper 5. Okay, so see you at that time. Take care.